Hello folks, hello everybody. Let me see if my sound is working fine. Let me increase that a bit. Hello everybody. Let me see if my sound is working fine. Okay, it seems to be working. Okay. Let me test one thing first. Okay. Hello everybody. We are live on YouTube, X, and also Twitch. So I think we can start. The live today will be very fast, but we will cover benchmarks during the process. The idea is very simple. We have started on work in the last session, and I have continued that off live, and then I will bring you some updates, and then we can discuss, and hopefully you can make some pull requests to Node.js. If you are in the chat, please send a message on Twitter or on Twitch. That also works. About the sound, please also tell me if you are listening things correctly. If that's good, we can start. So let me move to the screen. Let me check out main and move to this screen right here. Here we go. Okay. So one thing I can tell you all is the following. I have opened a few requests to Node.js. Hello, Johan. Sebastian, actually, right? Some of them were already merged. They were merged, I think, yesterday. Yes, yesterday. Let me increase the font size. And I will explain why we did all of this. And if you want to create a pull request in Node.js, hello Nico. I will teach you today. So the first thing, for those that want to create a pull request to Node.js today, please fork Node.js project, clone it locally. So when I send the patch, I explain the patch. You must understand the patch before opening the request, otherwise you are just copying my work, so this is useless. And I will explain that. If you understand, you are happy to open up a request, and I'm happy to approve that. Okay? So let me explain a few things. This is the track benchmark. I think that we have a few opened. We have this thing and this thing. The most important piece. Node.js, let me open I think this one. This is a fundamental, no, this one. This one is the objective of the yesterday's live stream. I sent in the chat. I will also send on Twitter and also on YouTube. Okay? So, Node.js benchmark suite takes a long time to conclude. I have been doing the state of Node.js performance for the last 2 years, 2023 and 2024. And the work I do is usually I run all Node.js benchmarks, and I compare that across different versions and different environments. I basically give you the output that Node.js is faster now, or we regressed somehow. However, this is a painful task, and that's why I wrote this Excel. To run the Node.js suite, the compare suite, the benchmark, it takes 85 hours if the machine is good, and if nothing breaks, because we have some benchmarks that relies on file system. So imagine that the file system goes out of space, so the benchmark will fail and you need to restart all of that. So, you know, it's a painful task. We have 426 files, benchmark files for Node.js, and we don't have all Node.js modules covered. I also wrote a pull request long time ago, which is benchmark coverage for Node.js. We will never learn that, but this is good for to have an idea. And this is the result of all files that were not covered, or all APIs from Node.js that were not covered. This is the list that we don't have a benchmark for. This is a long list, as you can see. So for instance, we don't have a benchmark for create require. We don't have a benchmark for the inspector open. Some of them is useless, you don't need to create a pull request, but some of them are important and we should have a benchmark for that. So we don't have a benchmark for the access, for chow, close. Those APIs are very important, and we must have a benchmark for that. And you know, that's the thing. So any questions so far? Can I explain why we did this script and why we did this benchmark? Please keep saying in the chat, that helps me. Okay. Hello, Michael. Michael Blair. It's better, right? Michael. Kiet. Okay. So, okay, let's move on. So we wrote this benchmark, and we wrote this tool that basically is this one. Let me send you the pull request. This one. We have a new API or a new flag to the benchmark of Node.js. You can run benchmark run.js -- track. This will track how long each benchmark file takes to run. This is very simple script. And then I have sent that to the Excel file, and we wrote this list. Then we know that to run this string decoder, we take around of 6 minutes just to run one benchmark, which means normally when we run the benchmark compare, which is we use a probabilistic model to validate if your benchmark is correct or not. Because sometimes you run a benchmark 2 times and then you compare the results and say, okay, my output is faster, so my code is faster. Now I can create a pull request telling folks these pull requests increase the performance of this API by, I don't know, X%. And that's not true. When you get just one sample of benchmark, it doesn't mean your code is faster. It might be just hardware variance and things like that. I wrote a lot about that. I have talks about it. So if you want to learn more about why this doesn't matter, check my blog, check some of my talks on YouTube. And also there is Node.js documentation that explains that a lot. Right. I've opened up a request to fix this using a new calibrate AN. One thing important is that whenever someone opens up, writes a benchmark file for Node.js, they write the following pattern. They have an option which is n. What is n? Is basically the amount of iterations each benchmark will have. So in this case, we receive n right here, and we iterate, and then we run. We call the function. This is not correct because most of the times the n here is arbitrary. Someone just put a random number, a big number, just to make sure that the benchmark is okay. but sometimes it's just make the benchmark is very slow and it's useless. And that's why I wrote the second, this benchmark, add, calibrate, and script. Basically, this script will identify the best n with the lowest variance in the benchmarks, and then we can find that. And that's why I have used that API or that script to create this pull request. I'm sending in the chat as well, also on YouTube and here, that improves how long the string decoder takes to complete. And as you can see in the Excel, we have the fixed pull request here. So these decrease from 5 minutes to 1 minute to run this benchmark. So the idea is to do that for the ones that takes a longer time and they have an arbitrary n value. Another golden rule when writing Node.js or JavaScript benchmarks. This code will be likely JIT optimized, okay? Why? Do you know why? Someone knows the reason for that? Someone knows why this is useless? Let me open the libOS. I didn't get the question. Could you repeat, please? Yes, of course. This benchmark, we are iterating and calling this function, and basically the bench start and bench end is basically performance now, const start, and then when it ends is const end is equal performance now minus start. This is how you measure the time elapsed in benchmarks, right? But why this benchmark is useless? Most of the time is useless, this kind of benchmark in JavaScript. Hello, just came from Discord. Hello, Vishal, how are you? No idea, to be honest. That's fine. When we run that once, V8 will say, okay, that's fine, let's run. When you run it multiple times, in this case, we are running it 3,000 times, V8 at some point will say, okay, you are calling CPUs, but the value returned by CPUs is not used anywhere. So it means that regardless of what this function returns, you are not assigning, you are not reading the value, so it's useless. I can optimize that and remove this. So basically, at some point, your benchmark will be just an empty loop, because V8 will use the JIT compiler to optimize it away, because it doesn't make sense. So what we usually do on Node.js benchmarks is the following. We assign that to a variable, v, and then if I just do that, it will not work as well, because V8 will also say, okay, you are assigning that to a variable, but you are not reading this variable anywhere. So I still can optimize that. So we do usually, we do a simple assert here, and then we are reading the variable, and then V8 will not optimize that away. So this benchmark is much more reliable than the previous one, okay? However, It does work when you are doing CPU or JavaScript work behind the scenes. If you are not doing JavaScript work, in this case, CPUs calls this function, which is a C++ function. Sometimes V8 will never optimize that, and that benchmark is fine. But most of the times is not. So it's better to do an assert. The only way to identify that is to use node trace V8. No, node V8 options. Oh, node trace opt and trace the opt. This will tell you when the function gets optimized away or not. Just out of curiosity, do the benchmarks have access to the internals or not? If so, is there a way to do it? This is something I'm interested in because in a pull request I made, I'm not sure if it's possible. Yes, that's definitely possible. One thing you need to do on benchmarks is the following. Here we go. When you create a benchmark, you have some options, and one of the options is expose internals. So you create the benchmark, you pass the argument that goes to the main, and the third parameter is an object that you can pass the flags to the Node.js environment. And when you pass the -- expose internals, you have access to the Node.js internals when you're running Node.js. Okay, let me see the Discord chat. Right, so let me find one pull request some of you can do. I think for the CPU ones, it doesn't matter. Let me check how we can do that. It's very simple. We do the following. I have edited the pull request, the file. I run the benchmark CPUs. This is taking some time. Usually the result is stable. Okay, and then if I revert my change, yeah, as you can see, the result doesn't change. So for CPU, this is okay. We don't need to change this thing, okay? One thing we can do here is the following. Sometimes this n is too much. As I said, people are using an arbitrary number. So we are going to use this function, the calibrate n. Let me check out the request because it was not landed yet. Hello, Iago, how are you? Long time no see, yeah. So we do node. Let me compile node. I think I have node here. Yes, I do. Benchmark, calibrate n, and then we pass benchmark OS CPUs. This is testing. Okay, it says on my machine that with 1,000, the results are stable already. So instead of using 3,000 here, we do 1,000, and the result will be will still be constant. So if we run that node, let me run node benchmark OS CPUs. We are taking now 0.04 seconds, and Previous, it was taking 0.62 seconds. Actually, I'm wrong, sorry. The time is usually elapsed on, this is on user time, system time. Oh, 3 seconds versus 0.1 second. So we have improved that by a lot. Okay? The only reason I don't open a pull request for that now is that I'm running the benchmark while doing live stream. So all of this means nothing because my benchmark will be affected by the OBS studio, by Twitch, all the browser I have open, the tabs. So most of the times I will not open up request. I will not run or trust in a result from benchmark while doing a lot of things. To do that, you need to run it in a dedicated machine. So if you want to create a pull request for Node.js for this specific patch, check out this pull request, okay? I didn't get the difference between the two executions. The reason is simple. Anything you pass on this object goes to the main, okay? Which is the end value. So this is the amount of iterations. Previously, it was 3e4, which is the same as node e3e4. Oh. 30,000. So we are running that 30,000 times, and calibrate n tells me that if I run it with 1,000, it's enough. So instead of running the benchmark 30,000 times, I will run it just 1,000. Okay? That's why it's very direct. What's the topic today? Hello, Mohammed. We are talking about Node.js benchmarks, all the work we have started last week, and we are continuing this week. I sent the pull request in the chat, so you can see. Okay, but this number is just for your machine or for everyone that will run it. Most of the time, it's for my machine, yes, but most of the times this will apply to any other machine because the CPU, what we are calling here, of course, it's because my CPU is fast, it's because my hardware is fast, but the reason we have the calibrate n is because we have dedicated machines for Node.js to run all Node.js benchmarks. So if you run that in your machine and the coefficient of variation is still low, we will see that 30 times is too much, 30,000 times is too much. So if you want to test it in your machine, do the following. Clone Node.js, and run this file. It's very simple, you don't need to compile Node.js. If you just clone the repository, you can run the following. Node. You need to check out my pull request, but that's simple. This is the command, and this is the pull request you need to check out. So this is the command, very easy. Okay, so as I said, I will not open up request to change it to 1,000 because I'm doing that on live stream. But we know that 30,000 times is too much. We just need to find a better value. Anything below that and more than 1,000 is good. It's fine. I need to use Node.js 25. No. You just need to use Node.js 24. That's enough. Install the latest version of Node.js 24, and that's good. Okay, so the next script in your, the next benchmark in our list is TLS throughput s2c.js, and let's see why this is low. Let me revert all my changes. TLS throughput s2c. Okay, we know. I already know the reason why this is very slow. We are doing too much, and we have many variations here of the benchmarks. Okay, we have a set timeout that. Okay, that the benchmark is not doing too much, but they are closing the, or they're having. I just feel that we need to change all Node.js HTTP or network benchmarks, because they, most of the times they take more time than necessary, and we might, it's useless to trust or to consider the socket of the machine as part of the benchmark. So instead of doing all of this, instead of creating a server and listening to a socket, we need to mock all of that and benchmark only the functions that does work. Otherwise, this is just taking a lot of time. But this is a more complex solution. I don't think we have time to do that in the live stream. Okay. We can move it on. This is net. Oh, we have write file promises. This is good. This is one thing very interesting to fix. Let me check. Currently, this benchmark is taking a few minutes to conclude, and for the compare, this is taking 255 minutes to conclude, which is useless. So let's understand why we what we are testing here and how we can improve that. We are testing all the encoding types, which is buff, ask, and UTF-8. Okay. We are also testing the size of the allocation of each chunk. So we have a big number here. I think the last one is possibly useless. This size is actually arbitrary. There is no need to have such big size. This can be removed. I'm pretty sure. The second one, we are repeating as the same chunk to the same chunk. Okay, that's fine. And then we are starting a benchmark. Then we create the function during the benchmark start, which is something we don't want. Okay, though the stop function should be outside of benchmark start. The write is the same. We don't want to declare the function during the benchmark. Why do you think the last one is unnecessary? Could you please explain the idea behind it? Okay, so let's explain why. What are these arguments? As I said before, any argument or any object, any row you put on this object will be called to the main. So what happens on this thing is the following. Test. Okay. We will call this benchmark when duration is 5 because it's the first parameter here, okay? When encoding type is buff, when size is 2, and when concurrent is 1. However, for each line of this benchmark, we will call all the benchmark again. So let me explain that better. The duration, we have just one, so it will be 5 for all benchmarks. But for encoding types, we have more than one. So here we will call the same for buff, for ask, and for UTF-8. Okay, that's clear. However, we also have multiple arguments for size, which means that we still need to do this object with a different size on this time here. The same applies to this. So this grows exponentially for each parameter, for each option you do here. So we will do that for this 124. Okay. So and then we still have for this amount of size as well. So we need to add one for this group, add one for this group, and add another one for this group. And then when you go to concurrent, we will still need to do one for 1 concurrence and 10 concurrence. So we need to double all the numbers down one more time. So that's why the benchmark takes too much, because we test each one of the configurations separately. We don't test duration, we don't test buff with size 2 and concurrent 1 just once. We test the encoding type buff with size 2, 124, 65,000, concurrent 1 and concurrent 10. So we have multiple variants of this benchmark. So that's why it takes so long. And the idea of this benchmark is to validate how much or what the performance of write file when the size is very small, when the size is still small, medium, and when the size is big. After this, we had 24 with versus 124, which is, if I'm not wrong, 1 megabyte. Bytes to MB. 1 gigabyte. No, this is not megabyte. This is bytes. So megabyte. I'm not very good on this. Yes, bytes with almost 10 megabytes. Okay, of chunk. Okay, so this thing doesn't make sense because either we test with something very, very big or we test with something medium. Those are basically, nothing will change between a medium chunk and a big chunk because the code is the same. We're using the same cache file and things like that. So that's why I thought about removing, but thinking more about that might make sense to just remove this one or remove the size 2. I don't know. Let's evaluate that together. Okay, moving on. Let me remove this. Okay. We test when buffer alloc. We do that on here. The encoding as well. Right? And as I said, we were defining all the things after the benchmark start, which is not good. So let me do that here. And we do a bench end. Okay, this benchmark is doing something very interesting. We are closing the benchmark based on time, which is on stop. So we have a row here to tell how many writes and writes concurrent. We start the benchmark time, and we plan to end it after 5 seconds. Okay, so this is the full time. However, it does something that it shouldn't do. Any file system benchmark must have a warm-up. Why? Do you know why? Someone knows why we need to have a warm-up for file system specifically? Can be, I think, this thing. Let me explain here. I think this might be a good thing. Whenever you open a file, this the file, so some of the bytes goes to the CPU cache and the system cache, which means that I have opened the file, I have read that file, it goes to the cache. So any access to that disk, or any access to the file again, it will be cached on the CPU. So when you start reading that, it will be slow because it will need to read to the file system, get that back to the buffer, and then place it to your application. You have the pointer and so on. When you try to read the same file again to the same location, you get from the cache. You get it from the cache. So that's why when you do the following, there is one. Okay, I set one. I think I have this on my personal repository. Cache, CPU cache. I think this might work. File system cache, Node.js. This is CPU cache. This doesn't. I can explain this later. This is very interesting. But when you, so what we usually do is that if you don't do a warm-up, the first benchmark, which is in this case the buff, will get the wrong, you'll get a cache miss, because when you try to read a file, it will check, okay, is this file or this pointer is cached in the CPU? No, it calls a CPU cache miss, and then it will read from the file, okay? So this is called cache misses. And whenever you get a cache miss, is something that affects the performance. So once you read that for a few times, it goes to the cache, and then after some allocations, you get it from the cache, and this will be very, very fast. Okay? However, for the buff, when you do that for the first time, the buff will be affected by the cache misses, but the rest will not be. So we can do one example here that might work. I'm not sure. Let me check. We do that. Let's assume that we have just buff and just one size to make it fast. Okay? And just one concurrency. Node benchmark file fs, I guess. Write file promises. Let me use my node. Let's see the results. 39 million times, or 39,000 here, 41,000. 40,000. Okay. Now let's do a warm-up. We do all the benchmark again, but before the benchmark start. So we do the write here. After write, okay, and then it will do I stop. Should end false. If should end, we call bench end, and then we run that, and then after this we do a should end true. Let's do that. Nope. So the first test will be the warm-up at the end, and it will be slower just because of it. Yes. As you can see, the result here, you know, we had 39,000, and now we have 75,000. This is cash. This is simply cash. So you can't really measure things because you are getting so many cash misses that the result will not be constant, you know? So maybe I did something wrong. Let me just double check, because I should reset everything after doing that. So let me move all of this. We have this, let, and then we just do that again. Right here, here. Okay, now it should be better. Let me see. Still, so all of these were just cache misses. Okay, so we should never do a file system benchmark without a proper warm-up. Okay, so if someone wants to create a pull request for that, I would happy to guide you. The only thing is that we need to understand here if this benchmark makes sense. Let me try to see if this makes sense, because we are using write file from promises. We are writing to a disk with a specific chunk. Then we use the after write, which doesn't make much sense in my opinion, because this is promise you can await, if I'm not wrong. I'm not sure if we have a sync function main. We do. So all of this can be simplified with async await. So let me try to do that. We revert all of our changes. We have here and then we have benchmark start. It's very simple. Let's do this. Benchmark start, await. Await write. And then we have write here. Write should be an async function. Actually, I don't need to have this here. I can write await. This is a promise, so we can await, and then this can be an async function. Oh, an async function. The write doesn't exist anymore. We have the writes. The writes can be still improved here. So, oh, this is because we do things concurrently. that doesn't make much sense, to be honest. This is about writing to the same disk concurrently, to the same file concurrently using the same API. Although this benchmark is interesting, I doubt we are caring about it, to be honest. So I would just rewrite it to the following. So I have writes, I have n, and I have bench and n. And then I do a temp dir refresh. I get the file name here. I can remove that, can remove this. The duration, the size, I don't know the duration. I think we should not I think we don't need to have times for that. These all can be simplified. Concurrent removed, duration removed. Let me just double check the other read file, for instance, we have here. Oh, they use the same approach. They use the same approach. We continue until the duration ends. So I think it's fine if we have a duration here. We don't need to have concurrent. So while we need to get a start. So const start time, performance now, while performance now minus start time. So instead of I here, let's use while. So while this is in milliseconds, so duration. So duration, as this is in milliseconds, this should work. This should work. Let me check. Of course, never works from the first time. Let me check what's happening. Files writing is not okay. Files writing is, let's start with 0 and then yes, this should work. This will take some time because we have many configurations. N is not defined. Let me check where I'm using N. Oh, bench and I think it's files writing. Yeah, it is files writing because it's how much files we write on this time. Okay. Yes, how much files writing in X duration, right? Yeah, that's correct. The previous logic was a bit more consistent, I would say, because we were also measuring how many bytes we're writing. So we are just saying, okay, n files were written, but we are not comparing how many bytes were written to the disk. So this benchmark is not 100% compatible with the previous one. But I'm just writing that to understand what's going on. If we can simplify that somehow. So yeah. So we have two actions here. The first one is there is no need to change how this benchmark works for the first benchmark. We just need to do a warm up. So you can create a new function warm up, or no need. You just need to do what I did previously. We reset variables. So we have that here. And we call the for again 2 times. That's it. This should work, and this should be changed to let. If someone wants to create a pull request, this is the thing. Let me create the gist for you. Here you go. I sent in the YouTube. I sent here. Create the dist. Create the pull request. Tag me. Testing your local machine. See if the results is also consistent as it was in my machine. If it was fast. If this is fast, and then we can move it on. But this is the final action. I can continue the live stream in the next session next week, but I have to close now. So I hope you all have enjoyed the live stream. Time flies, and let me see if we have someone working with Node.js to send a small raid, but it never works. Okay, we have one person working with Node.js, I guess. I'm just doing internet tricks, but not sure what he's doing. He's doing hacking. Let me see if we have other folks doing things. No. I need to create a pull request from which branch? From main. If you create a pull request from main, that's fine. Just make sure to ping me. And also, before I open the pull request, run make linked. Let me check if we have some issues here. I don't think so, but yeah, it's fine. It's fine. Just create from this diff, and this should work. Oh, there are people working with JavaScript, I guess. Okay. I'll start the rate. Folks, thank you for watching the live stream. It was great. Um, I hope I have some time to do more things during the week to prepare for the next session. And also, again, if you haven't followed me on YouTube and social media, please do. And join the Node.js mentoring on Discord, official Node.js Discord, or Slack channel. I normally announce when I go live there. And that's it. I rate someone that is working with Node apparently, and say hi to them. Bye bye. Oh, we have 10 seconds still. See you. Bye bye.
And they didn't take any args, right? So we're just gonna